Hello friend, how are you? I hope you are all will be fine. I am also fine, thank you. How was the study? How is the study going? So let's today is the lecture number 10 of crystal field theory. What is the topic name of crystal field theory and today lecture? In today lecture we will be applying crystal field theory to tetrahedral complexes. Is one application of crystal field theory, that how tetrahedral complexes follow crystal field theory, how crystal field theory can be applicable, as how can we apply the crystal field theory to tetrahedral complex. Before we starting the lecture, first of all I am just going to show you to, let's imagine there is cube like your room. Let's suppose if you consider, if you imagine your room, you are now sitting in your room will be like that. In your room there is 8 corner, 4 corner is on the ground and 4 corner is on the floor. So 4 corner is on the ground and 4 corner is on the floor. So let assume that in the middle of the your roof of room, your room roof, there is fan. Let's suppose if one ligand are, if the fan is one ligand, if one ligand is placed at in the place of roof, in the place of fan in roof, and three ligands are placed in the three corners, in three different corners on the on the three corners of the ground corner. There is 4 corner among 3 corner, any 3 corner. If you take three different ligand on this corner, if you place this ligand, if it is the if it is the way, if these corner are the way of approaching the ligand towards central metal atom, and in the metal in between the ground and the roof, there is, let's suppose, is metal complex, metal ion, central metal ion is present. If there is central metal ion present, it means that this central metal ion will be like that, that it will be uh, equally distance from all the points from the three corners of the ground, as well as from the fan of the roof. So like that, this will be considered, this will be act as a, this will be act as a tetrahedral complex, this will be act as a tetrahedral geometry. So you also know that there is 4 sides. One side is like that, one side is like that. The 6 side, totally 6 sides. One from this one and one from this one, like that. Yeah, like that. That is above the border, and one from the inside of the border, and one from the outside, one from the upper side and one from the ground state. Let's suppose there is 6 side, one is the ground state in your room, and 4 are the walls of your room, and one is the roof. So totally 6 sides. If these are the axis, if these are the axis, like that, is that right? If um, east and west or north and south, if one of them are axis and one of them are y axis, and the up and down are z axis, then what will be happen, it will be axis, while the ligand and direction, the different corners, the ligand will be act as in between the axis. So if it is will be in between the axis, it means that ligand will approach easily to T2G sets. T2G set as the set that is that has orbital that which are in between the axis. So T2G orbital will be overlap, T2G orbital will be faced effectively as compared to the orbital that are lying on the axis, like EG orbital. EG orbital will be will be less effectively faced. Is that right? So now let's start crystal field splitting energy for tetrahedral complex. So is it right? Now I'm just cleaning the board. Okay, let's suppose there this is tetrahedral complex. How can I will be formed tetrahedral complex in 3D shape? So in 3D, how you can make, how you will be made the tetrahedral geometry? It will be like that, that this is the one plane, this is the second plane, this is the third plane, and this is the fourth plane. Tetrahedral geometry will be like this. Is that right? Tetrahedral geometry will be like that. One from in this direction, one in this direction, one in this direction, and one will be from the other side. While uh, the point where all the planes are meet will be the point of will be the place of central metal atom. So how a tetrahedral means tetra means four, while hedron means face, means there will be four face. So how four face will be formed? Four face will be like that. Also let's see, this is the one face, this, yeah, right, this is the one face, this is the one face of this system, and this is the another face of the system, and this is the another face of the system. These are three face, and one face will be like that. So these are the four faces of tetrahedral. I mean, the axis will be like that. That will be x-axis. That will be y-axis. That will be z-axis. So these all orbital are in between axis. So that's why the ligand will be approach T to G set effectively, while E G set cannot be for while the energy of each set will be lowered, while the T to G set will be increased, because T to G set because the ligand are approaching in the way that T to G are come in the way of the ligands. So is that right? Okay, let's start forward. So as you see that the T to G orbital, T to G sets will be more, T2G have more energy, because T2G set has more interaction, the orbital of T2G set has more interaction with ligand, because it is because the ligand are approaching in the way because the ligand are approaching in between the axis, so that's why T2G has more has more interaction with ligands. T2G orbital has more interaction ligands with ligand, while so that's why T to G orbital will be increased in energy, their energy will be increased, their energy will be increased, but eg set eg set it will be it will have less energy, or their energy will be decreased, their energy will be decreased. Why it will be decreased? Because the ligand are approaching to the central metal cation on in between axis, while Eg orbital are lying on the axis. So that's why Eg orbital will not be effective interaction, will have not be effective interaction with ligand, but the T to G will have effective interaction, because these orbital are in between axis, while also even the orbital, the ligands are also uh, approaching to the centimeter atom in between x. That's why eg t to g orbital will have high energy, will energy increase, while eg set will be decreased. We can write this in this form also. How? Let take the correct position of camera. How? So this is, let's suppose this is the d orbital, all have same degeneracy, the degeneracy are same. These are degenerate orbital. If we are approaching the ligand, if ligands are approaching to the central atom, first of all, let their energy will be decrease slightly, will be increased slightly, but it will be degenerate orbital. These are d-orbital. D-orbital, these all orbital are degenerate orbital. When ligands are approaching to the central atom, first of all, the energy of the system will be increased slightly, but when the ligand continue their approaching to the central atom, finally the energy of T to G will increase slightly, while the energy of EG will decrease slightly. Is that right? EG energy is decreased. EG has two orbitals. EG has two orbitals while T to G has three orbitals. dxy, dxz, dyz, dxy, dxz, dyz. While that EG orbital has dz square, dx square minus y square. These orbitals. These this distortion is the in tetrahedral complex. Tetrahedral complex. So, is that clear? Be remember in tetrahedral complexes there is the EG script. The EG subscript will be not used. It will called the EG orbital will called E orbital E set, while T2G orbital will called T2 set. The reason behind this is the T2G set is not used for splitting of d orbital in tetrahedral complex because a tetrahedron has no center of symmetry. A tetrahedron has no center of symmetry. Is that right? It has no center of symmetry. The symbol G is used for the ligand field which have center of symmetry. That's why that will be called T2. Well, the EG set will be called EG. The dz square and dx square minus y square set orbital set will be called E sets. While the orbital of dxy, dxz, dyz are called T2 sets. Is it clear? That's point. While the splitting in this is E set, this is T2 set. While the the energy that is decreased, due to the E orbital. This is, let's suppose, that is normal position. So this is energy decreased and this is energy increased. The total energy decrease in increase is called and tetrahedral complex it will be called delta T, while in octahedral complexes it will be called delta naught. O means not means O means octahedral complex used for octahedral complex, while T means T is used for tetrahedral complex. So this splitting will be called, means the crystal field splitting will be called delta T in case of tetrahedral complex. Crystal field splitting in tetrahedral complex will be called delta naught. Delta T, sorry. Delta T, it will be called delta T. Is it clear? Okay. But there is one point. Delta T will be always less than delta naught. In case of octahedral complex, the splitting will be greater, but in case of delta T, while in case of tetrahedral complex, delta T or the splitting will are be lesser. It is because in octahedral complexes the ligand are there are six ligands, and in tetrahedral complex there are four ligands. There are four ligands, four coordinate number of central atom, while in octahedral complexes there is six coordination number. Six coordination number are six ligand are used. So that's why six ligand have more interaction with central atom, while four ligand have less interaction with central atom. That's why delta T will be less than delta naught. The another reason for delta T is less than delta naught is that delta naught is the ligand are approaching in the way that on the axis that's also the Eg orbital are lying the axis, so the interaction will be effective interaction will be present. But in case of delta t or in case of tetrahedral complex, the ligand are approaching in between axis, but the interaction between the ligand and the orbitals of the T2 sets are the ligand are the orbitals that are in between axes are not enough are not effective like the interaction in between delta naught. So that's why the delta T energy will be the delta T splitting will be decreased while the delta naught splitting will be higher. So delta T will be less than delta naught. This these are the complex as well as you uh, the splitting will be like that. The splitting will be like that for in delta naught in octahedral complex it will be like that. It will be Eg, it will be T2G, while in case of in case of tetrahedral the splitting will be like that. That will be E orbital, that will be E set, that will be T2 set. So here is the splitting is very late, here is the splitting is small, but here in octahedral splitting is larger. So that's why here can be high spin. So in case of tetrahedral complex the splitting is very less, while in case of octahedral complex the splitting is higher. So that's why here only be here will all electron will be unpaired according to Horn rule. It will be follow Horn rule. But so high spin complex will be formed, high spin complex will be formed, but low spin complex cannot be formed because here is the splitting is very little. If the splitting is little, the spin will be high. uh, if this if the splitting is low, so it will be follow Horn rule. According to Horn rule, first all the orbital will be paired, singly paired. After that pairing will be started. uh, but in case of delta naught, high spin and low spin both complexes will be possible. It depends upon the ligand, the strength of the ligand, that this ligand are strong or lesser. So these all are about tetrahedral complex. So in next lecture we will be studying that how what is the D system, number of electron in D system, how can the what will be its effect on the tetrahedral complex if the d system hang electrons. So is it clear? Also we will calculate crystal field stabilization energy in next lecture. Okay, is it clear? These are about crystal field theory and tetrahedral. These are about crystal field theory for tetrahedral complex. Okay, thank you. I hope you will be cleared. That is lecture number 10. Okay, thank you. Best of luck, best wishes, and be read, be careful. And if you have any problem, if you have any questions regarding the lecture, you can ask me. If you have any question, any problem, if you have any problem in the chemistry, you can WhatsApp me, you can contact me on my WhatsApp. Okay, thank you. Best of luck, goodbye.